So, the two more types of sediments are remaining, that is biogenous sediments and hydrogenous sediments. So, the first one last class I told you, that is the constituents of the biogenous sediments. So, first one is calcareous, this is calcium, mainly calcium carbonate. Derived from shells of marine organisms. The next type is siliceous. So, this is derived from silica, or you can write mainly opal. So, this is hydrated silica. This is derived from shells, end shells of diatoms. So, last class I told you what are diatoms and radiolaria. So, these are marine organisms which have small, which have I think pseudopodia like and all that I have told you. Now, the last variety is phosphatic. So, three types: calcareous, siliceous and phosphatic. So, these are again mainly from bones. Scales of fish. Further. Now, these are production you write organisms by organisms living in the sunlit portion of the waters. Sunlit waters near ocean surface. So, this is production. Now, destruction or dissolution. Dissolution means they get dissolved in the sea water. So, eventually eaten by big fish, or you write by big fishes and skeletons, stroke shells broken into smaller particles. Now, after this they get deposited on the ocean bottom. Now, dilution greater than 30%, biogenous continuous, biogenous constituents. So, if the sediment has greater than 30% biogenous constituents, so it will be called biogenous sediment. Now, if lithogenous particles are present in large amount, then biogenous sediments cannot be formed. So, this is the drawback. The last one is the hydrogenous sediment. So, we have finished with biogenous, lithogenous, biogenous, and the last variety is hydrogenous sediment or formed from water. So, this originate from inorganic chemical reaction. This is inorganic chemical reaction in seawater over a large period of time. Formation of manganese nodules. So, as a result of inorganic chemical reaction in seawater, manganese nodules are formed. Now, what are these? So, composition is complex mixture of iron manganese minerals. So, you will find the maximum quantity is the actual percentages I have not got, but in your, if you look up journals, they will give you the percentage of manganese, iron, then you have nuclear trace elements. That is why people are running after these. Such as cobalt. Cobalt is also a nuclear element. So, that is also found. Then you have iron, manganese, copper also is present. So, these are excavated from the sea floor. Excavated from sea floor by a process called ocean mining. So, basically these are dredgers. for deep ocean. Pacific Ocean, more than 50%. Covered with manganese nodules. But exploitation is lifting these to the surface and recovering the minerals, that is called ore dressing, exploitation and recovery of minerals. Expensive. That is why do not have commercial exploitation right now, still in the research stage. So, it is the minerals that you extract, that is mainly iron, manganese, copper and nickel is also present. Copper, nickel and the nuclear elements, that is cobalt. Their extraction and recovery of these minerals from large depths in large amounts is still not possible, but it is still in the research stage. Now, formation of nodules takes place very, very slowly. So, mankind is exploiting the natural resources of the ocean very fast. First, it is extracting all the oil, then it is extracting all the minerals. So, after a few hundred years, you will be left barren. So, formation of nodules takes place very, very slowly. You write, this is one of the slowest chemical reactions. Slowest chemical reactions known. The reaction speed is 1 millimeter or less in thickness. Formed in 1000 years. So, this is one of the slowest chemical reactions, but we are fast exploiting this resource just after your crude oil. Now, so with this we have finished the sediment part, that is related to your ocean floor. Now, let us see what happens in the open ocean. So, this is the last of your physical oceanography. In the open ocean, there are oceanic processes. Now, these are dominated by incoming solar radiation. So, ocean is actually a great heat sink. So, if mankind is able to use this huge amount of solar radiation that is coming onto the ocean surface, solve most of your energy needs. But unfortunately, we have not developed technology for this. Now, this incoming solar radiation this is called insolation. The oceanic processes are influenced by heat coming from the sun, that is called insolation. And what are the other processes? Other processes are winds, light and temperature. So, these play a important role on your climate. Winds, light, temperature. Of course, temperature is also influenced by incoming solar radiation. So, these are some of the aspects which influence our. The last one, of course, is salinity. How much saline is your seawater? Now, later on you will find that salinity influences density of seawater, and as a result of change of density you have ocean circulation. Now, because of this phenomena of insolation, causes three-layered structure of open ocean. So, that is the main water body in the ocean is divided into three distinct strata. Now, from this diagram you can see. Now, what are these strata? You will find the first one is called surface zone. So, the ocean waters are stratified into three layers. First layer is called surface zone, second layer is called pycnocline, zone. Pycnocline is where you have maximum density variation, and the last one is called deep zone. Now, from this diagram you will be able to make out what are these three zones. So, this is what is happening in the open ocean. Now, this water mass you divide into 3 regions. The middle line is near the tropics or the equator. That is, our country is mostly affected, or it is in this region, equator. On the other extreme you write South Pole. Opposite you write North Pole. And depth, we are interested up to 4 kilometers below the ocean surface. So, this is 4 and here you have 2. So, this is 1, 2, 3 and 4. So, let us study the layer that is affected by these oceanic processes are limited to 4 kilometers below the surface. So, this is depth in kilometers. Now, what happens between the North Pole and the South Pole covering the equator? You write this is 50° north, this is 0° your equator, and this is 50° south. Now, you have a surface zone. Now, this is even less than 1 kilometer in thickness. So, it is going like this from the North Pole to the South Pole, and you can see in the equator actually the depth of the surface zone is decreasing. Now, next you have up to 2 kilometers, you have the pycnocline zone. The diagram actually goes like this. So, the top one is surface zone. Next you write pycnocline zone, and below that is the deep zone. Surface zone constitute 2% of the water mass, followed by 18% in the pycnocline zone. Rest how much is there? 80%. So, deep zone waters constitute 80% of the water mass. So, this is the distribution of the 3 layers between the North Pole and the South Pole. Now, from this diagram, so let us first analyze this, what is happening. So, what is happening at the surface? That is called the surface zone. So, surface zone obviously will undergo major changes of what? Major changes in temperature. So, this zone is the most affected by the incoming solar radiation. So, this is affected by major changes in temperature because of seasonal variations in heating. So, you have to have a good knowledge of thermodynamics if you want to analyze the rise in temperature. So, later on I will give you an equation where you can calculate the heat flux. So, seasonal variations in heating, cooling, and as a result of this heat also you have evaporation. And precipitation. Now, your maximum evaporation and precipitation will occur near the tropics, and formation of sea ice. In polar regions, or rather you write polar zones. Now, surface zone contains less dense water. The density is less. That is why it is remaining on the at the surface. Density is high, obviously this will go down into the depths. Now, this zone has derived from these two words. Now, after this we end the surface zone. Now, next is your pycnocline zone. So, ocean engineers who are doing ocean thermal energy conversion, so they are interested in this layering of the water and what is the change in temperature. So, pycnocline zone, it has derived from these two words, that is pycno is density and cline means coming from incline. So, that means slope. So, there is a large density gradient in this region, large changes in density. Now, what happens because of this? Because of large changes in density, you have ocean circulation. Okay, so that we will come back later. Now, this zone is particularly stable. What is pycnocline zone has great stability. Now, because of this stability, what it is doing? So, it is mainly undisturbed, whereas the surface zone is affected by temperature and wind. So, has great stability. So, this acts as a barrier to vertical water movement. So, from the diagram that I had drawn, you can see this zone, that is this zone, pycnocline zone. Now, here from this diagram you can see at the equator this zone is deepest, that is the depth of the layer is the deepest at the equator. So, that means at the equator the deep zone waters cannot come to the surface. So, this zone is acting as a floor for the surface zone and acting as a roof for the deep zone. But here you will find near the poles, that is the south pole at the north pole, there is no pycnocline zone. So, that means at the poles the deep zone waters can come to the surface, there is no barrier. So, a lot of circulation of the ocean waters take place at the poles rather than at the equator. So, the equatorial zone is more affected by solar radiation, acts as a vertical barrier to vertical water movement, serving as floor to surface circulation. With its temperature and salinity. So, in the poles, is it advantageous or disadvantages? At the poles, you can see from the diagram that there is no this pycnocline zone, and deep zone waters can come to the surface. So, that means there is a vertical circulation. So, that is conducive for fishes, for the movement of the food for the fishes, and you will find rich fishing fields in the Arctic waters. That is the main reason. Serving as a floor to surface with its temperature. So, temperature and salinity of the surface zone does not go below. So, this also acts as a ceiling for deep zone. Or rather you write for deep zone waters. Now, the mechanism is prevents deep zone waters to readily mix with surface water. So, prevention of mixing is taking place or equilibrating with the atmosphere. So, that is, it is mostly unaffected by winds and incoming solar radiation. So, polar regions, I told you, this is absent. So, what is the climate of the polar regions? Right, pycnocline absent. Deep ocean waters. Exposed at surface. Leads to exchange of gases. So, this is what is taking place at the poles. Gives up excess CO2. Carbon dioxide and takes up oxygen. And this process is facilitated by strong winds. So, in the polar region you have storm conditions, that is strong winds and waves. Polar regions are relatively, the environment is relatively harsher than your equatorial region. So, in this region, so you do not have the pycnocline barrier. So, what happens here in the polar regions? Due to absence of pycnocline, one I told you is the rich fishing harvest that comes from the ocean bottom. The other is more important, which affects climate, is large water mass movement. So, you will notice just below the Arctic region and on top of the Antarctic region, you have huge circulation of water mass. So, large water mass movements, and these are characterized, or rather you write identifiable by characteristic temperature and salinity. So, you have removed the barrier. So, now what you get is a global ocean current circulation taking place at the Arctic and Antarctic. So, large water mass movement identify characteristic temperatures and move through ocean basins. What is the ocean basin? So, ocean basin is in the diagram, that is seafloor diagram that I have drawn, is the bottommost part of the ocean. So, that is occurring at the deep zone. So, at the deep zone you have the basin. So, you can see in this diagram that the ocean basin will come here just below the deep zone. The deep zone is lying on your basin and there is a huge circulation going across, circulating throughout the globe at the Arctic and Antarctic region. So, that is the what is called geostropic current. There is a huge current. So, later on we will discuss this. There are types of currents that are taking place in the ocean. So, this we have finished. The last one is of course a little bit about the deep zone. So, this deep zone has also some characteristics. One I told you is this. So, this is mainly isolated from surface zone. This is its main characteristic. By what? By the pycnocline zone. So, this is one of the characteristics of the deep zone. Now, as a result of this, there is no heating cooling. No exchange of gases. Deep zone waters are cold. Average temperature is 3.5 degrees and 3.5 degrees centigrade. And surface water temperatures can vary from minus 1.7 degrees centigrade to as high as 30 degrees centigrade near the equator or the tropics. But deep zone waters, because they are unaffected by the surface zone, you will find mainly around 3.5 to 4 degrees centigrade. Now, another characteristic is light absent. So, if you happen to go below 4 kilometers from the ocean surface, you are in perpetual darkness. So, that is light is absent in deep zone. As a result of this, there is no photosynthesis. So, how you are going to communicate in the deep zone? Communication in deep zone waters is mainly done by strong lights. If you have a submersible, then you should have a focused light as one means. So, if any object is on the ocean floor, so that means if you want to retrieve it, you should have strong lights in this submersible. The other means of communication is by noise or by sound. So, communication in deep zone waters. Communication in deep zone, flashlight, strong flashlights. From submersibles. And acoustics. So, these are the signals. So, if you want to retrieve an object which has sunk, the Titanic pieces or the Konishka crashes, then you have to scour the ocean floor with strong flashlights and sonar. This is called sonar arrays. You have to take help of this. So, underwater communication is done in this method. So, no photosynthesis. So, then what happens? So, most food for the fish is consumed in the deep zone. So, these are imported from surface. Or carried by turbidity currents. So, turbidity currents, I told you, they are mainly caused by earthquakes in the deep ocean. So, they are the main carriers for your food for the fishes. There is no other way, because other is if you can extract some food from the surface zone in the polar regions. In the equator, of course, you cannot do anything, because your pycnocline barrier is coming. Now, the next is the solar radiation. Now, prior to going to this solar radiation, we should look at the wavelengths. Now, what are these wavelengths? Now, the oceans are mainly affected by two parameters. What are these two parameters? Both come from the sun, affected by light. And what else? Heat. Light, heat, and there is another parameter which affects Sophonard, what I have told you, this is called wind. Now, in the meteorological studies, you will find wind is also created from the heat, that is the solar insolation that is coming to the earth. Now, before we go into this, let us have a look at the wavelengths. This I cannot finish out here. So, this is your scale, and light wavelength is coming somewhere here. This is 10 to the power minus 14. Cosmic rays. Gamma rays. In short, I am writing like this. Wavelengths are in centimeters. Now, the reason is, what is the reason behind the sea looking blue? So, the deep ocean waters, if you look at them, they are blue in color. What is the reason behind this bluishness? Water absorbs less of blue light. The light or white light that you see consists of seven wavelengths, out of which the blue is the least absorbed, mostly it is reflected. So, that is why in the eyes you will see blue waters. So, the ocean waters are blue. Now, before I think we have less time. So, now what is this infrared doing? Now, infrared radiation is cause of heat in the ocean. So, this is quickly absorbed. Within 1 meter. next you have the visible part. So, I will give you this diagram next class. Now, this consists of 7 wavelengths. Now, before that, in the scale where we come, this visible light will be somewhere here. I will give you the others scale. This is 10 to the power minus 4. This is your visible light. So, next class we will finish this and discuss about insolation. Okay, thank you.